Hello everyone, I am Pradeep Sharma from Civil Engineering. I am studying at the University of Wollongong. Selected my topic as the geopolymer, the sustainable construction material. In the next slide, I would like to introduce about the geopolymer concrete and the sustainability aspect of this concrete material in the engineering world. Let me talk about the sustainability aspects. In the social, economic, and environmental benefits for the people, society, and environment, we know that there is an essential need of sustainable construction materials because the land is limited and uh, the available resources are also may not be renewable in the long term. So here we introduced the geopolymer concrete, which has various advantages over the existing ordinary Portland cement, which we call OPC concrete. The sustainable construction material has a longer service life because the materials are reused and recycled over time, and the global warming potential can be reduced through this. The carbon emission and then the maintenance cost as well as the life cycle cost saving can be done through the sustainable construction materials. Those recycled industrial waste can be reused and recycled over time under the life cycle assessment. The energy and resource, as resourced by the Govindan Shankar, says that the geopolymer can be recycled in the form of energy saving also, because the saving of energy is conducted through the transmission of heat, and the heat generated during the manufacture of concrete, like for example when we develop the OPC concrete, then in that condition the carbon emission could be more than 7% in the world record, but that emission could be controlled, and a systematic approach could be done through the geopolymer concrete. The further research has been done by various researchers, like in the geopolymer concrete. I have researched through the such papers and came to some conclusion with it. In the next slide, uh, I would like to continue with the alternative of such materials, like what we call is the binder material, like a geopolymer. The geopolymer can be replacing the cement content, because the binding content of a geopolymer, which we can see that the solid content can be obtained from the aluminosilicate resources, like clay and fly ash, and the liquid content can be through the alkaline activator. So the alkali hydroxide and alkali metal silicate can be mixed together as a binder material in the form of silicate and alumina, and forms the geopolymer. That geopolymer can be demanding nowadays because the environment and cost effective advantage has raised user friendly approach and in the various content. Likewise, um, I like to talk about the cost effective and durability of this element, because the various researchers have researched on this topic regarding the durability, like how durable is the material over time, and the research shows that the compressive strength of the material increases with the curing capacity. Like the strength of concrete depends on the curing and the heat hydration. So in terms of that, the content of the material within the geopolymer concrete can maintain the increase of the compressive strength as well as the decrease of the compressive strength. So the other bases like tensile strength and mechanical strength are the part of the compressive strength. In consideration of that, there are various challenges that we face during the analysis of the sustainability aspect of geopolymer concrete, like the content of the fly ash, like how much content that we are going to add in the geopolymer content, so that the sodium hydroxide could be limited in the range, because sodium hydroxide plays an important role in inducing the heat in the concrete, and the induction of heat can emit a greater amount of the carbon dioxide into the atmosphere and affecting the environment. In the next slide, I'd like to talk about the research question that those research papers gave me various research questions like how the geopolymer concrete defines all those materials in terms of the content, in terms of the advantages to the environment, and the various related works done by the researchers over time, and the design, appropriate design of the geopolymer concrete in this process. In the next slide, I am talking about research question. So geopolymer concrete has influence over efflorescence and shrinkage effects, because the concrete may shrink by some amount due to the heat and then generation of emission of heat, as well as the we can say that the shrinkage effect could be due to efflorescence, and the challenges could be behind the generation of heat and carbon dioxide emission to the atmosphere. So these are the research questions in terms of research questions in terms of the available resources done in the world. In the next slide, uh, I'd like to talk about the related works that I found helpful. Like we can see in the figure that the curing time is affected by the various content of the foam and the bond strength. Like we can say that geopolymer foam concrete. Researchers has done a research on the geopolymer foam concrete, where the OPC concrete is placed as the alternative part for that. Like the research shows the thermal, mechanical, and shrinkage properties, where geopolymer concrete was found highly beneficial in compared to the OPC concrete, and the compressive strength reduced, which may be the limitation part of the concrete. So in that condition, the ambient temperature, like the enclosed temperature, can be maintained so that we can maintain the compressive strength required for the concrete, and likewise the workability of the concrete can be increased at the same time. Another research in the topic could be the CO2 emission. That in this research, the reduction of emission of CO2 was observed by the various experiments, like the cost evaluation and environmental benefits as well. Like the researcher has taken 1 meter cube of volume of concrete, and compared with the OPC concrete and the geopolymer concrete, where the cost evaluation was highly beneficial in case of a geopolymer concrete. So the sodium hydroxide content and the stock of those elements have been considered in the consideration of efflorescence and heat generation by the researcher. In the next slide, I'd like to talk about the design process. Like I have approached to the design process of innovative approach of material synthesis, like how the synthesis of material is done over the constituent materials, like how the silica and alumina are added to the content of geopolymer concrete, and how the strength and workability, like there may be some strength and weakness of the polymer concrete, then how those strength and workability could be determined. And such kind of experiment is necessary in case of alkali activator, how the alkali activator could be used as a super plasticizers in geopolymer. So in this regard, we can come to some preference that the sodium oxide and calcium content can be maintained, so that the greater workability could be maintained. And in the mixed design approach, the temperature constant, like how the temperature could affect the content of the, like in the curing as well as the strength generation, the temperature plays an important role. So the concentration of sodium hydroxide and the nature of curing, how we like enclosed or in the exposure to the atmosphere, how we are going to get experiments over that. So in this case, we can get the all those answers to the research questions related to the efflorescence and hydration, that how the content of various materials generated could be helpful in this regard. And in the next slide, I'd like to go with the references that I have used and researched in this paper for getting those outputs, as well as the fruitful output in the topic of sustainable construction material as a geopolymer concrete. Thank you, and any questions is appreciable.